Hi, I'm back, Dr. Alexi. I'm coming back to continue about the question on comparator. I'm actually looking now at page 13 of your lecture notes when you have this uh, example 1, okay, in which, as you can see over here, the input signal to the plus terminal is a sine wave, and your terminal, negative terminal here, is grounded to 0. And the output is specified to swing between plus V saturation and minus V saturation. So as you can see over here, this sine wave signal is going into the non-inverting terminal, which is the V plus. So you are required to sketch the output voltage. Now, quite easily, you should be able to remember the rule governing this comparator. The V plus, if it's greater than V minus, your V out will be equals to plus V saturation. Similarly, if the V plus is less than the V negative, your output will tend to be the minus V saturation. This is the most important fundamental that you are required to remember. So moving on to here, the output, as you can see, will be a square wave, as you can see, because this is a zero crossing comparator in which the negative input terminal is grounded. Okay, is grounded. Now, looking at this waveform, it's very easy to know that the positive cycle, as shaded over here, of the sine wave is going to be greater than 0. So therefore, when it is greater than 0, your output will go into a positive V saturation, as you can see. Now, when the voltage at the positive terminal now swings to the negative cycle, it is less than 0, as you can see, and therefore the voltage now would swing to minus V saturation, as you can see. So the op-amp input is connected to the signal source and the minus input is grounded. This is how we analyze the comparator circuit in this example over here. Now I would like to revise with you on the example number 2, in which we have already done, and this is on page 15 of your lecture notes. Now in this question, the input signal is given as a 5-volt VRMS at 1 kHz sine wave, and you are asked to do a few things. Okay, please take note that the reference voltage is at 3 volts. So first of all, you need to determine this sine wave, what is the peak voltage. So we know that your VRMS is equals to V peak divided by square root 2, and therefore your V peak in this case will be 5 volt times square root 2, which gives me 7.07 volt peak. Okay, now let's take a look at this question again. So you are required to sketch the axis, okay, and number 2, you are required to draw the horizontal reference voltage line, which is 3 volts. Okay, so let's put that down, and you are required to sketch the waveform. Now looking at this question, it is easy to straight away identify that your frequency is 1 kHz, and therefore we know that frequency is inversely proportional inversely proportional to 1 over t. As you can see, f equals to 1 over t. So the period t is easily known or calculated to be 1 millisecond. So in order to sketch this graph, okay, what you have to do is to draw a x and a y axis, in which this is time and this is your amplitude, right? So first of all, we would sketch a sine wave, okay, in which the peak voltage will be 7.07 volt peak, and it of course swings to a negative 7.07 volt at the other negative cycle, and the time between here to here will be 1 millisecond. So similarly, at this point in time, we would draw the reference line. Let me just assume that the reference line is over here and it's 3 volts, right? As determined in the question over here. 3 volts. The reference is 3 volts, which goes into the negative, the inverting terminal of the op-amp. So by drawing this, okay, we will realize that the output of the operational amplifier will no longer be a square wave, and is going to be a rectangular wave form instead, because your reference voltage is no longer at 0 volts. So over here, if you may sketch, okay, your op-amp would start, this is plus V set and here is minus V set. So because of this point here, your signal here is less than 3 volts. Alright, this signal is, sine wave is going into the non-inverting terminal. Right, so if I would sketch, the waveform would start from minus V sec and it will swing up to the top. When the sine wave crosses the reference voltage of 3 volts, it will swing to the positive saturation. So as you can see, okay, you may be able to sketch this yourself, but just to take note that you are doing a comparison between the positive terminal and the negative terminal for the operational amplifier. That's all for now.